So big round of applause for Emma. Thank you.
Hello. My name is Emma. I'm the co-founder of a small company called Levit. It's a Belgian company. You may have heard of me because of one of those two libraries, your schema adapter or embassy-like utilities, which allow you to create complex form and do complex data management out of Django, Ember.js, and the schema adapter. But today I'm not going to talk to you about that. I'm here to talk to you about Python running on different devices. But before I start doing that, I'd like to take you on a journey. Small journey back in time, about 35 to 40 years back in time. And about 40 years back in time, you could find this magazine. This one is from 1971. And in 1971, you learned that creative and computing go together, which seems quite normal right now, but 10 years ago, it was not the case anymore. And you can also see that in 1979, computers were not just for boys. It was for everybody. And notice the floppy disk holder, which is blue, which nowadays seems normal, except we don't have floppy disk anymore. But you've got, I'm pretty sure some people in the audience have a blue laptop or something like that. But try to remember in the 90s, your CD case holder, it was all black. Everything was black or sometimes white. But you didn't have colors. In 1979, you could have a blue floppy disk holder, or yellow one, or red one, and it was perfectly fine. Also, around the same time, this is a book that you could buy. And once again, how to make robots is something that we could find in the shelves today. There's not much on this book that you can see that could tell you it's not a book from today, except maybe for that CRT screen on the left. But this is something that we've been talking about all weekend with Raspberry Pis and microbit and everything. And this was normal in the beginning of the 80s. But by the end of the 80s, this was not normal anymore. There's been some kind of void that swallowed everything that was creativity around computers. Computers were not for creativity. Computers were for numbers, for working, not to be creative. And robots, come on. No, not robots. Yes, robots in assembly lines, maybe, but not this kind of small robot with an arm that could lift something up from your desk. And so still in the beginning of the 80s, if you had maybe a Commodore 64 or a BBC Micro or ZX Spectrum, you could find instructions in that book on how to plug your robot into your computer. And this here at the bottom is the user port of a Commodore 64. It looks, if you can see it, it looks a bit like the bottom edge of a microbit. It's the same thing. It's an edge connector. The only difference is that it's two-sided. But this means that if you had a Commodore 64, you could experiment with your computer. You could take alligator clips with a bit of insulation so that you don't hit both sides at the same time. But you could take an alligator clip and clip it onto your computer. And from there, you could control a robot. That was wonderful. But unfortunately, by the end of the 80s, this was what people had at home. This is actually my first computer. It's a Philips NMS 9115. It cost a fortune. But yeah, this is my first computer. It's an IBM compatible. Yes, that's what they were called at the time. It's an IBM compatible, and on that there's no user ports. There is nothing that you can actually plug things in. I just use the term IBM compatible. If you want to be immersed at the time where this came as a word, this became something. You may want to watch Halt and Catch Fire. I recommend it. It's a series about a TV show about the first IBM compatibles and how they came to be. It's quite accurate. Of course, it's a fiction, but it's still quite accurate. When I said that you could not plug robots into IBM compatibles, or I'm going to say the grandfathers of the PCs that you have if you don't have a Mac, that's not exactly true. I lied to you. What you see here is a parallel port and 2 serial ports. And so if you were an engineer, you probably knew what those did, and you probably knew how to write code in C to be able to access those. And well, on the Commodore 64 and the BBC Micro, you could do that in BASIC. You could access the port, the user port in BASIC. BASIC, as its name says, is pretty basic, and it's available to everybody. Everybody can try to do BASIC. Writing C is not for learners. But you could still access those in C. Also, another difference is that on the Commodore, if you had a Commodore, the voltage was 5 volts. 5 volts is something that you find on the Raspberry Pi today. It's common electronics voltage. I'm not sure about the parallel ports, but the serial port of a PC runs at 10 volts. So if you try to plug in any electronics, you might as well fry it. And that's if you're lucky. If you're not lucky, you're going to fry the computer. And I just said that this was really expensive. The NMS 9115, I believe, was around £2,500 when I bought it. So that's quite more expensive than a ZX Spectrum or a Commodore 64. So if you're a kid in the end of the 80s, you probably don't want to touch those, because if you fry the computer, your parents are not going to be happy at all. If you fried the Commodore 64, they would not be happy either, but they're going to be really, really, really mad if you fry that one. But, so I talked about that void, but then came the Raspberries. Oops, I'm sorry, that's not the right Raspberries. These Raspberries, the Raspberry Pis, and this, for so many reasons, was the end of the void that swallowed creativity and everything. This is the end of it. Now we've got a fully fledged computer, because this is a computer, the size of a credit card, where you have a ton of GPIO pins accessible. It's a fully functioning computer that runs Linux. And from the very start, the Raspberry Pi Foundation has been very interested in promoting Python. I'm not sure if they intended it because of the name Python, if they wanted it to be together. Yes, somebody says yes. But anyway, the Raspberry Pi has been thought as similar of Python by many people. When I go to the electronics shop and I talk about the Raspberry Pi, they say, oh, the thing that runs Python. Yes, that's it. That's a Raspberry Pi. And we're back, because the PCs still cost quite a lot of money. But this is £35 in the UK, I believe, 30 or 35 pounds in the UK. So if you fry one, yes, your parents are not going to be happy, but it's okay. If you fry the Mac at €1,500, your parents are still not going to be happy. So what I'm going to say now, I know that some people here are not going to agree with me, and they want to throw tomatoes at me. Please don't. What I'm going to say is that BASIC and Python are very similar languages. Let me explain. They are both interpreted languages. This means that you can type in something and directly see the result. They have simple syntax, And so if you want to print something, you just type print whatever you want to print, and it works. This is what I mean by they're very similar languages. For somebody to learn to use Python or to use BASIC is really easy. You can write a program in 2 lines, it will work, it will not do much, but you can do print hello world, and it will work. Now if you take Java, you cannot do print hello world. Meanwhile, so that was the Raspberry. This is not a Raspberry anymore, this is an Arduino, and this didn't wait for the Raspberry Pi. The first Arduino actually came out in 2003, I believe. And what the people who produced the Arduino wanted to do was a bit similar to what the Raspberry Pi Foundation did with the Raspberry, is that they wanted regular programmers to be empowered to be able to program chips. Programmable chips are not new, but before the Arduino, to program a programmable chip, you needed to have some hardware, you needed to have a chip writer, you needed to have something that was capable of big banging the program on the chip. This was revolutionary. Yes, I'm okay. Because all you had to do was plug it in, and then you had an editor, and you can program in C and send your program, compile your program, send it to the chip, and it will run. So that was really great. But as I said, you don't want to take an 8-year-old kid and teach them C as the first language. If you show a kid that's never programmed anything, you show them C, chances are they're going to run away. So enters the bugs and bits. 3 years ago, I went to PyCon UK in Coventry. And I was introduced to this little thing, which is a code bug. And the code bug runs MicroPython. I also heard about a secret project of the BBC, which was the microbit. And those things go further than the Arduino, because you don't have to program them in C. I believe you can program the microbit at least in C, but you don't have to. And if you choose to program them in Python, it's really easy to do so. You just plug it in and drag your compiled file on it, and it will restart and work. So this was starting to make programming chips available to anybody, not just programmers who already knew C. It made programming chips available to 8-year-old kids. I'm speaking about 8-year-old kids a lot because I started coding when I was 8-year-old. It can be an 11-year-old. It still works the same. Let me check my notes. Yes, but those devices were not the first devices that were able to run Python on a chip. There's the ESP32, who's also capable of running Python on a chip. The main difference between those two and the generic ESP32 is that those two were designed with kids in mind. So when the microbit came out, it came out with a really good documentation and a bunch of little tutorials designed especially for kids or for people who just had never programmed such a thing before. It was starting with the hello world of the hardware Python, which is lighting up a LED. And this is the documentation, and those tutorials is what made things more available to everybody. So now after the microbit and MicroPython, I cannot do this talk without talking about Adafruit and CircuitPython. So for those who don't know it, CircuitPython is a fork, a friendly fork of MicroPython. The major difference is that it is run by a for-profit company that pays people to write open source code, to write open source CircuitPython. And CircuitPython is a fork of MicroPython just mainly because they wanted to have Python running on other chips. These things here run ATSMD21 and ATSMD51 families chips, which were not supported by MicroPython. So they forked it. I believe they send changes upstream every once in a while. And not only do they pay somebody to work on CircuitPython, they also pay a lot of people to write tutorials, to write guides, and to write open source drivers for sensors, for NeoPixels, for lights, for plenty of stuff. They pay people out of their pocket to write open source and to make everything open source. And when I say open source, I don't only mean the software. Most of their hardware is open source as well. So you can go to their website, download the schematics, and build it in your garage if you want to. You don't have to buy it. So let's move a little bit away of those things. And let's talk about other kinds of computers, the computers you all have in your pocket. Smartphones, tablets too, although you don't have that in your pocket, I hope. If you want to do Python on those devices, it may not look like it's possible because either Mac or Android, they are making sure that you can only put certain things on the app stores and everything, but there are two frameworks that allow you to write Python code and have it run on mobile phones. The first one is Kivy. It's the one that's been around for the longest. They mainly focus on UI and letting you write native UIs for your phones in Python. I'm talking about this in relationship to mobiles, but you can actually compile the same code for mobile or desktop. It will all work. The other one I want to talk about is BeeWare. BeeWare is less known, it's more recent. It's a little bit more active than Kivy because it's newer. There are two main reasons why I want to talk about BeeWare. The first one is that you may have seen my little dog here. And my little dog is a personal friend of Brutus the bee. So, of course, I had to talk about BeeWare. Another good reason I had to talk about BeeWare is that BeeWare is not just one thing. It's a series of tools that let you run Python on different things. And one of the things BeeWare is used for is for compiling the Mac version of Mu, the editor for the BBC microbit. So now for the question that's on everybody's mind. What about my smart toaster? Please raise your hand if you have a smart toaster. Nobody. Okay, so we can skip that. Now, if you have something like a smart toaster, smart light bulb, smart anything, you want to be able to control it. And you can also do that with Python. So these are three different Home Assistant devices. There's the Amazon Echo, Alexa, the Google Assistant. This is the DIY version of the Google Assistant. And this is Mycroft. I'm going to talk a little bit more about Mycroft in the next slide. But all those platforms let you program skills in Python in one way or another. So Mycroft here, if you've never heard about Mycroft, it's an open source home assistant. It runs out of a Raspberry Pi. Most of the code is in Python. And they focus on your control over the machine and privacy. So you've all heard about Alexa sending a bunch of audio to the web. One of the main features of Mycroft here is that you have to say the keyword before sending any data to the cloud, while Alexa sends your audio to the cloud in order to see if you said the keyword. So that's a big difference. And so I'm talking about keywords. That's how you program skills. You define keywords like light, on, off. You define sentences with keywords like lights on, lights off. Those are two sentences. And then they call actions that are written in Python. So this brings us to the end of this talk. And what about this talk, you might ask? The most keen observers among you might have noticed that I have this big chunk of cardboard in my hand since the beginning. This is a clicker with a cool laser. I don't have sharks, but I have lasers. And the reason I have this in my hand is that I've always wanted a clicker with a laser. I want a clicker with a mouse. Where's my mouse? It's on the other screen. So I'm moving my mouse with my clicker here. I can click it, I can go to the next slide with it, and this all runs Python. What I've got in my hand here is a LowPy, which is a MicroPython module. It's wireless. It can communicate via Wi-Fi, Bluetooth, and LoRa. LoRa is a radio protocol, and this one communicates over LoRa to this device, which is a feather that runs CircuitPython. It's also LoRa enabled. And so whenever I do something like move my mouth, this little receiver receives that information and translates it into HID instructions. And it's recognized as a mouse plus keyboard by my computer. And so this is MicroPython, CircuitPython, they talk together and works really well. And so this is the end of my talk. We have maybe time for one question.
Okay, thank you, Emma. Let's give Emma a round of applause. Okay, so we do have time for some questions, and I am under strict instructions to make sure your question is actually a question. So if you raise your hands, I'll come down with the microphone for you to ask a question. So any questions for Emma? Okay, fair enough. Well, what have you found the most interesting bit of the things that you've messed with recently and the different devices that you've used Python with?
What you can do, like for example, this clicker, this is something that's made for me. It fits my hand. Yeah. It's personalized for me, and so I don't really need one. But one of the projects I've seen that's done with MicroPython is somebody who is disabled and cannot move at all. And so to drink, they have this bottle, kind of bottle of water with a really big straw that comes up. The problem is that since they cannot move at all, if they want to drink, they still need to call somebody to move the straw and put the straw into their mouth. And someone created a little device with a trinket, I believe, but anyway, a MicroPython device with a servo and a push button on the arm of the wheelchair. So now when that person wants to drink, they press on the button, the servo moves, pushes the straw where they can reach it with their mouth, and so now they can drink. This may seem like really not that much, but for that person, this means they can be more independent and they don't rely on somebody to come and push the straw when they want to drink something.
Yes, I'll just come down to go.
Thank you very much for a lovely talk.
You're welcome.
I'm really inspired to go home and do some stuff now. But questions, right, I promise. Do you think that change of scale that we've had, back from those big, expensive, you mustn't touch this, we can only afford one of them boxes, back to something small and affordable and everyone can be playing with them, is helpful in perhaps getting girls interested again because they're not going to be elbowed out from using the great computer?
It's not enough by itself. I was a kid in the 80s, so I saw it go the other way. And go the other way is that there's been some pressure from the toys companies and all that stuff to say, computers are for boys. So no, this is still something that a lot of people think, and we have to do something to say, no, computers are for girls. There's a lot of things going on, and the best way, if you look at what you can do online with a microbit and all that, you will see quite a few girly girl things that you can do. There's a lot of things that you can do with NeoPixels, like hairdresses with NeoPixels and things like that. And I'm not saying that this is only for girls, but this is something that mainly girls are interested in, and it is with this kind of material that we are going to get girls interested in computers, I think.
Thank you, Emma. I think we're out of time now, so let's just give Emma another round of applause. Thank you very much.